Please.
Okay, so we will start this quick exam. The main idea is that you can explain us a few things in your point of view or considering all the knowledge that you got from the class. Okay, so my first question is, in terms of productivity or efficiency in your workstation and the work with the sub-assembly, what were the things that you improved and that you will improve,
Mm-hmm.
and the things that you have done a very good job, but if you affect other stations or not.
Okay. First of all, I think that in our station we can improve. We have very small things that are in the subassembly, and that small things, there are a lot of small things, and those things made the subassembly more that has more time, and this could be that one improve that we can make, that this maybe have less things. And other thing that I can see in our station is that we can improve the tolerance of our fans, for example, for better put better the fans and those things. And I think that we could improve, maybe put the things more quickly, because at least in our turn it was very inefficient, deficiente, sorry, for that, because I wait for the another stations to grabar los videos, and that makes that our station was low in time.
Okay, so my next question will be,
Mm-hmm.
why did you use a PLC robot?
PLC what? Sorry?
Robot.
From bro. Oh, okay. For why we use? Firstly, because it was the challenge. Use that it's the goal of the question, right? Or
No,
I
yes.
I don't get it very well.
So,
Uh-huh.
why did you use?
In general, why you?
Yes.
Okay, because we need to use control in our station to. The PLC firstly is like the main thing that you use for control, like the robot, like that send us the control of everything, like the LEDs, the robot, the interlock, and those things. And in our case, we use the PLC to program, like to send the signals to the robot to know when the robot needs to do the things, and also, for example, when the operator opens the door and detects the safety of the station, when it's closed the door and can start the operations, and those things makes the PLC, and that's why we use PLC. Alan Bradley, why? Because it was a challenge for us, because the other stations use Siemens, but in our station was Alan Bradley for those reasons, firstly. And we don't use HMI Alan Bradley because we don't have the license, but that's another question, I think.
The next question and final from my side is explaining what's the process to generate a G code and how you will run it in the CNC.
Okay, you mean in Fusion?
Yes.
Or all the process. Firstly, you need to have your parts on, for example, on Fusion, on SolidWorks, and later of that, you need to create the operations in that software that depends of what you want to do. For example, the milling or drilling or other operation, You need to select the operations there, calculate the spindle speed, the feed rate, and other things to know, and also select a good tool. Could be in Kenda Metal, and all of those things depend. Also check what is the material for calculate those speeds, feed rates, and those things. And later in the simulation of fusion, you need to put all the process there, and it will appear a simulation. If the simulation don't have errors or warnings, you can export the G code there, and later during the CNC you can export it in a USB, and later put it in the CNC code, and you select what first. You need to have your block. You point the set point where you need to, when it will start the machine. All of the tools, you need to create a offset of each of the tools, also the